All right, in this video, we're going to talk about state machine, or some people say it's a state diagram. So we can convert the state diagram into a circuit, sequential circuit, or we can convert it back, which is from a sequential circuit to a state diagram. But however, the chapter is called state machine. Sounds like some kind of machine, but it's not. It's just like a state diagram. Okay. So let's take JK flip-flop as the first example. Because we know that the sequential logic, the output of the sequential logic is determined by not only the input and also the previous output. For example, we call it Qn. And now we are looking at Qn plus 1, which is the next state, the next output. Since we have QJK, 3 binary bits, so we have totally 8 combinations. So all these 8 combinations. And now let's take a look at that. So when we have all these combinations, what is this next state will look like? Since the previous state is given and the inputs are given, we should be able to get all this Qn plus 1 here. Okay. So when Q is 0, we call this the state of we call it a 0, it's S0 or state 0. When it is 1, we call this is state 1. Okay. When J and K are zeros, which means this is a memory. So memory will memorize the previous state, so which is 0. 0, 1 is going to pass J to it. And what is J? Is 0, right? If J is 1, it's going to pass 1 to it. If both JK are 1s, then it's going to toggle the previous state. So we are going to get a 1 here. And when both JK are 1, it's a memorize the previous state, and then pass J, and toggle. Okay, this is how we do that. And now we can convert this stuff into a state diagram or state machine. So S0 is the first state, right? And you have S1 is the second state, S0, S1. And now let's see when this guy is staying at the same state or it's jumping to another state. And we are using JK since we already have the state here as a Q. And JK will be the condition for the jumping between or to itself. So now let's see. When your JK are zeros, so the state jumps from 0 to 0, right? Which means the JK combination is going to jump to itself when JK 0, 0. And when JK 0, 1, it also jumps from 0 to 0. So at these two conditions, if the result is at S0, it's going to jump. It won't jump to anywhere else. It's going to stay at the same state with this kind of condition. And now let's see the next. So it jumps from 0 to 1, 0 to 1. And the condition is 1, 0 or 1, 1. Either one, okay? And now here it jumps from 1 to 1. Do you have another jump to 1 to 1? Yeah, 1 to 1, 1 to 1. So the condition is 0, 0 and 1, 0. And also you have the state jumps from 1 to 0. Just go back. 1 to 0, 1 to 0. So the conditions are 0, 1, 1, 1. All right. So that's the complete state diagram for this JK flip-flop. Okay. Now, stuff are becoming more tricky. So here's an example. If there's a circuit given to you, can you convert it into a state machine or state diagram? So circuit, this is pretty important, keep in mind. Circuit converted to a diagram. Okay, so circuit looks like this. It's going to take me a while to draw it. And here you go, here you got an OR gate, and that's Q1. And you have AND gate, and here is a T flip-flop. And this, and here is a NAND gate. NAND gate has input there, and this, so the signal is called X. It's going to the OR gate, and this signal is feeding to the AND gate. This is going to there, and here is a feedback from Q1 actually there, and Q2, here's Q2. Wait, so that one shouldn't be connected to there. There's nothing there, so it's connected to Q1, and Q2 is being fed back to this point. All right, yeah, I think that's it. So for this kind of sequential circuit, and we need to convert into a state machine. It looks like there's nowhere to start with, right? But however, there's a pretty routine, SOP, standard operation protocol, to convert it into a state machine. But in the beginning, you need the truth table, right? Since you can find out, we actually get the we have a truth table first, then we have a state machine. So we have a circuit, we don't have the truth table, so let's make the truth table first. Q1, Q2, X. So you need to know what are the inputs for the circuit. If you look at the left side of the gates, X definitely is one of the inputs. What about others? So actually the previous state of Q's is being fed back to the left side of the gates, so they are inputs as well. That's why I put Q1, Q2, X here as inputs. And what are the outputs? Intermediate outputs, JK, T, Q1, Q2, but the next state, and Y. Yeah, let's do it. So JK, so JK and JK will get the next state Q1, not this one, but the next state. And also T, and T will give you the next state of Q2. And also Y and Y prime. So Y prime is the next state of Y. Okay, so that's all the input output. So inputs, output. And we know all the combinations for Q's are 0, 0, 0, 0, 0, 1, 0, 1, 0, 0, 1, 1, 1, 0, 0, 1, 0, 1, 1, 1, 0, 1, 1, 1. That's all these combinations. And we still don't know what are these outputs are. So before we do that, we need to write down the logic expressions to convert the inputs to the outputs. So what are they? Okay, now let's put it here. So for example, the first one we need to know is J. So what is J? J is actually X bar, X naught, and what? Q2. And what is K? K is X or Q2. What is Q1 prime? Q1 prime is the output of the JK flip-flop, right? So it depends on JK. And you have 0, 0, 0, 1, 1, 1, 1, 0, right, for the JK. And 0, 0 will be what? 0, 0 will be 0, 0 for the JK is actually a memory. 0, 1, you pass J. 1, 1. 1, 1 is, wait, 1, why do we do 1, 1 here? 1, 1 is the last one. So 1, 0, we are going to pass 1 to it. And 1, 1, we'll toggle that. We'll toggle whatever Q was, is going to toggle it. Because this is a master slave, right? It's going to toggle Q1 bar. It's going to be toggled. And what about T? So T is Q2. So Q1 NAND Q2. So what is Q2 prime? Q2 prime, you need a little truth table here, right? So T can be 0 or 1. It's a T flip-flop. If it's 0, it's going to be a memory because no changes. But at 1, it's going to toggle that. So that will be Q2 bar. So what is Y? So Y is Q1 and Q2. Okay, these are all these things we need to know whenever we are plugging all these outputs there. We need these things. So now let's do it one by one. It's a lot of work. So X bar and Q2, which is J, X bar and Q2. So when actually you can make a shortcut over here because whenever you get a 0 in either of these two terms, you are going to kill the AND gate and have a 0 at output. So X bar or X bar and Q2, definitely this is 0, 0, X bar, this is 1, 0, 0, 0, 1, 0. Okay. What about K? X or Q2. X or Q2, only when you have two zeros, you are getting a 0. Otherwise, they are all ones, right? What about this? Q1 prime, the next state of Q1. You need to look at 0, J and K and previous state of Q1, right? So if JK are zeros, JK are zeros as a memory, and it's gonna state whatever the Q1 was, and that will pass J to it, that will toggle it, that will pass J, that will memorize, that will pass J, that will toggle, that will pass J. What about T? Q1, Q2 bar. Q1, Q2 bar, right? 1, 1, 1, 1, 1, 1, 0, 0. Q2 prime. So when T is 0, it's a memory. Otherwise, it's going to toggle that. So mostly they're going to toggle the previous Q2. So toggle, 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 toggle. So it's going to be a memory. So memory, memory. So what about Y? Y will be So y is actually q1, q2. So y prime will be q1 prime, q2 prime, right? So let's see. Y is q1, q2. It's unlogic. Pretty simple. And this one is the AND logic for these two columns, which is 0, 0, 0, 0, 1, 0, 0, 0. Okay, let me check really quick before we move forward, see if these are correct. 0, 0, 1, 0. Yeah, I'm comparing with conclusion from my notes. If this is correct, which means this time our calculation is right. Right, looks correct so far. Yep, no problem at all. Yeah, so we are, I definitely repeat the work I did before. So this is correct. And now let's find out the state machine. So now it's way easier. We find out the truth table. It becomes a little bit easier. It doesn't like from here. It looks like stuff from nowhere. It's pretty hard. But now it's not like that anymore. So let's put the result, the final result, as a combination of Q1, Q2, and Y, or Q1 prime, Q2 prime, and Y prime with as a next state. Since they are combinations, they're happening at the same row, which means they're happening at the same time. So we can definitely do this, right? Q1, Q2, and slash Y, /Y. That's a state we're going to talk about. So now let's see. In the beginning, we have 0, 0, 0, right? And the condition, so that's a state. The condition is X. So 0, 0, 0 is one state. It jumps to 0, 0, 0. It jumps to 0, 1, 0. Jumps to that when X is 1. And then you have 0, 0, 0 jumps to 0, 1, 0 when X is when X is 0, when X is 1. So both can make this jump happen. And now you have 0, 1, 0, 0, 1, 0, 1, 0, jump to 1, 0, 0. Do we have 1, 0, 0? We don't have 1, 0, 0. When X is 0. And then 1, 0, 1, 0 jumps to 0, 0, 0. Go back. When X is 1. Is that right? So far? Looks right. And the fourth one, 1, 0, 0. 1, 0, 0 jumps to 1, 1, 1, 1, 1. We need the 1, 1, 1. When X is what? 0. And we have 1, 0, 1, 0, 0 jumps to 0, 1, 0. We have 0, 1, 0, 0, 1, 0. Just go back when X is 1. And then we have 1, 1, 1 jumps to 0, 1, 0. Go to there when X is 0. And finally, we have 1, 1, 1, 1, 1 jumps to 0, 1, 0. 1, 1 jump to 0, 1. Wait. 1, 1, 1 jumps to 0, 1, 0. Okay, it's the same jump. So both 1, 0 will make this jump. Okay? And we're done with the state diagram. So see, in the beginning it's pretty hard, and so all the steps, keep in mind, once you see a circuit like that, what's the first step? Find out the input. That's step 1. Find the input. And step 2, output. Right? And step 3, you just find the logic. That's step 3. And step 4. So actually you fill them in, which is the step 4. And that's step 5. You just follow whatever you got from in the truth table. You can convert it into a state diagram. Okay. I'm sorry for it's too many stuff. I want to fit in one page because it's easier to find out where are they. But it looks like too crowded in here. Hopefully it's not giving you any issues over there. And the next example, we are trying to convert it backwards, which means we're going to convert a diagram into a circuit. Into a sequential circuit. That's what we are going to do. And now here is that as a given state machine. Zero, one. Wait, what I want to put here? I think it's 0. Right, 4 states, and that's x is 1. That's x equals to 0 or 1, and that's x equals to 0, and that's x equals to 0, x equals to 1, and that's x equals to 0, and x equals to 1. Right, these are all these things, all these conversions. So we have state machine, how to convert into circuit. Still, we need the truth table to be in the middle to make it look having more sense for us. Q1, Q2x are the 3 inputs. Q1 prime, Q2 prime, y and y prime. Okay, and still we have all these combinations. All these combinations, and let's take a look at that. So the state is actually Q1, Q2, and y, right? The condition is x. The state is Q1, Q2, y. Let's see. Q1, so 0, 0, 1. We only have this state, right? So 0, 0, 1. 0, 0, 1 will jump to, so when x is 0, it's going to jump to where? 0, 1, 0, right? 0, yeah, let's use a different color. 0, 1, 0. And now, 0, 0, 1 will jump to, when x is 1, it's going to jump to here, 1, 0, 0. Okay? And 0, 1, 0, no, 0, 1, 0, 0, 1, 0, when x is 0, it's going to jump to 1, 1, 0. Right? And 0, 1, 0, 1. So for 0, 1, you only have 0, 1, 0, right? 0, 1, 0. When x is 1, it's going to jump to 1, 0, 0. And 1, 0, 0 will jump to, when x is 0, it's going to jump back to 0, 1, wait, no, 1, 2, 3, 4, I think I'm done for, wait, see if I'm right. 0, 0, 1 will jump to 0, 1, 0 when x is 0, which is right. 0, 0, 1 will jump to 1, 0, 0, 1, 0, 0 when x is 1. And 0, 1, 1, 0, 1, 0 will jump to when x is 0, it's gonna jump to, oh, hey, here is not right. See, 0, 1, 0, no, 0, 1, 0. When x is 0, it's going to jump to 1, 1, 0. So that one's right. And now the first one, 0, 1, 0. Will, when x is 1, will jump to 1, 0, 0, which is right. Now the fifth one, 1, 0, 0. When x is 0, it's going to jump to 0, 1, 0, which is right. And 1, 0, 0 will jump to, when x is 1, it's going to jump to 1, 1, 0 here. And then 1, 1, 0 will jump when x is 0 or 1, doesn't matter. It's going to stay. So we're done for the truth table. And next step, we need to convert it into a circuit. So whenever we are converting a truth table into a circuit, we are looking at separate columns and do it one by one. But you can see that actually for the y prime, it's all zeros, which means it doesn't, you don't need it. It's the same as y because it's just totally nothing. There's totally zero. It's like a ground. It's always ground. So you just ignore that. Doesn't matter at all. Okay. And now, let's get the truth table first. The K-map first, because it has a couple of terms. It's probably tough to eyeball it and simplify it manually. So now let's get the Q1 for Q1 prime first. Q1 prime, and the inputs are x, Q1, Q2, right? 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. So now let's see. When x is 0, so what are these ones here? So this one, 1, 0, 0, 1, 0, 0, you got 1 here, and 0, 1, 0, 0, 1, 0, and this one, 1, 0. No, this one is the second one is different. So it's 0, 0, 1. 0, 0, 1 is here, not here. And then 1, 0, 1, 1, 0, 1. And then 1, 1, 0. And then 0, 1, 1. And then 1, 1. Okay. These are all this stuff you want to simplify. So how to do that? It is 4 and 4, right? That's it. So Q1 prime equals to, that's just x, right? X or, and this 4. So x got toggled. You only need, so this is toggle as well. So it's only Q2. So x or Q2. Okay. What about Q2 prime? Q2 prime. Q2 prime, just do it in the same way. X, Q1, Q2. 0, 1, 0, 0, 0, 1, 1, 1, 1, 0. Now let's see. Q2 prime. The first one, 0, 0, 0. This one, 0, 0, 1. and this one 0 1 0, and this one 1 1 0, and this one 0 1 1, and this one 1 1. Right, something like that. You group that, you group that. So what is Q2 prime? That one is just X bar. That one is Q1. Okay. What about Y? Last one we need to figure out. What is Y? Only 2 ones, which is great. So we only need what are they? Yeah, let's still got a K map just in case we, whenever you are pretty used to K map, you just keep on to use it since it's so convenient. 0 0 0 1 0 0. Yeah, right. So it's going to be Q bar, Q1 bar, Q2 bar. Okay. So if we have all these logic expressions, can we get a circuit? So the answer is definitely yes. So since Q1, Q2, they have next state, so you will need a D flip-flop over there, right? Definitely. So it's serving to make a delay and have next state. So X. So let's get the first one. So what is a Q1 prime? It is X or Q2. So Q1 prime, which is the next cycle here, actually this pin will be Q2 or X. Okay. And Q2 prime is X bar or Q1. X bar or Q1. Yeah, I'm gonna draw it really nicely. Or Q1, that's Q2 prime. So what about Y? Q1 bar, Q2 bar, right? Q1 bar, Q2 bar. Q1 bar, Q2 bar. So what is that? Y should be Q1 bar. Yeah, you can just add an inverter, and add them together, so get the Y. And Y prime just nothing there. It's not anything. So that's Y, and that's the final signal for this, starting from this state diagram in the very beginning. So this can be, you need a lot of time to do analysis. It's not that super straightforward. Your brain can resolve, right? So you have to draw it, write it down, do analysis, and check it along the way. So hopefully this helps, and you guys will have a pretty simple homework assignment on this to practice on this kind of stuff. And so we are pretty much done for the semester for all these required sequential logic and combinational logic stuff need to be covered. And the last thing we'll do, which is the last video, which will be a FPGA video, we are going to program the Verilog FPGA using a Verilog hardware description language. So which is actually the final application which people are in the industry are doing with all this logic stuff, which is great to learn. Okay, and we'll see you next video. Thank you for watching for this video. We'll see you later.